Hello friends, welcome to lecture number 6 of alternating current. In the previous lecture what we discussed? Bandwidth and quality factor, sharpness of resonance. But today in this lecture, I'm going to discuss about one device. One more device is going to be in your syllabus, in your copy. One more device. Device means we have discussed already some devices in physics. What devices are used for measurement or to do some work? Meter bridge, one device. Potentiometer, one device. Galvanometer, one device. We have discussed many devices. Today another device, one more device is going to be added in your copy. What is that device? Transformer. The device is transformer. We'll discuss today. Transformer. Transformer means I think all have seen one English movie, Transformer. So the name is like that. Okay. So from this device the name is given like that. Transformer. It's a device, electrical device. So we'll discuss about this transformer. Have you seen transformer? First come to the day-to-day life. Where you have seen the transformer? Have you seen it? Yes. Where you have seen? Yes, sir. I have seen this transformer just at the end of our street. Just at the end of our street. Or I have seen this transformer also, sir, in our school. Also, sir, one transformer is connected in our apartment. So you have seen that transformer just at the side, roadside, you have seen that transformer. But why that transformer is used? You have also little knowledge about that. I know you have little knowledge about that. You know that transformer, if you ask you this question, the answer must come from your side. You are thinking this answer. The transformer decreases voltage. Some 440 volt is coming to that transformer. The transformer decreased to 220 volt, then that comes to our house, isn't it? So this type of answer you already know about the transformer. You have this much knowledge about this. So you are correct. You are not wrong. You are correct. The transformer decreases voltage. It changes voltage. Then you now ask to yourself, except that roadside, have you seen the transformer anywhere else? Have you seen it anywhere else except that roadside? You pause the video here and think. And think where you have seen except that roadside I am telling to you. Think about this. Then you play the video. Where you have seen such device which change voltage. Okay? So if you thought any device, then it's right. Any place, anywhere, any such device used called as a transformer which changes voltage. If any answer come to your mind, then it's right. But I'm telling to you, those who thought the answer that just in your room, you look to the top of the walls, you see one stabilizer is connected there or not. One stabilizer is connected there or not for your AC air conditioner. Stabilizer is there. Maybe for some other electrical equipments if you're using at home, stabilizer may be required for that. And you may have kept it at your home. Stabilizer. What it does? What the stabilizer do? Yes. Also you have little bit knowledge about that. So the stabilizer increases voltage. Voltage is not sufficient for our air conditioner. That increases voltage and maintain required voltage for the air conditioner or for the AC. So stabilizer increases voltage. Okay. Then just at the end of the street, the roadside, what transformer you have seen? That you are telling decreases voltage. So now you got the answer. What is the function of the transformer? What is the function of the transformer? Transformer is an electrical device. Electrical device. I am not telling electronics. Electrical and electronics, they are two different branches in physics. Electrical device which changes voltage. Which changes voltage or which converts low voltage at high current to high voltage and low current, and vice versa. And vice versa. What I told you, just carefully now listen. Low voltage, I told at high current to convert to high voltage at low current, and I told you vice versa, means this one also it can do. It can convert low voltage to high voltage as well as to high voltage to low voltage. Accordingly, the current will convert. Now the question is coming to your mind, sir, we had the knowledge that transformer changes voltage. That street side transformer converts a high voltage to low voltage. Our stabilizer at home, that converts low voltage to high voltage. But from where this current term comes, that we don't know. Current, that we don't know. We know about it changes voltage, that's right. But current term, so that one clearly I will discuss now when I will enter into transformer. But for just 1 second I can tell you to understand that power is always a constant. What power is coming, electric power is coming, that is always constant. And power is equal to voltage into current. Power is equal to voltage into current. So if voltage increases, then current has to decrease. You see, low to high voltage, current high to low. Just to try to understand here, but mathematically I'll explain you when I'll enter into this transformer portion. So when voltage increases, then current decreases. When voltage decreases, then current increases. Because electric power, how much supply is to our house, how much supply is coming, that is constant. That we cannot change because that's energy for time. That we cannot change. That's why when voltage increases, current decreases, and vice versa. So you will not write the definition of transformer that only it changes voltage. Also current automatically change. So the definition you have to write in exam. It's a device which converts low voltage at high current to high voltage at low current, and vice versa. This is the definition of the transformer, and what it does now you understood. You also have seen the transformer in day-to-day life. I have seen that one. Okay, so on which principle it operates? What is the principle? If it's a device, it must operate in some principle. In exam, the question comes, what is the principle of a transformer? Mutual induction. Mutual induction, two coils. You all have remembered it, two coils. Okay? When in one coil current change, then in other coil EMF induced and current pass without touching. You all have remembered, I have told you that mutton is cooked in your neighbor's house but smell comes to you, and vice versa also, that mutual induction. There is no connection between them. This is the principle of transformer, that when current changes in one coil, EMF is induced in the neighboring coil. So this is the principle of the transformer. Then let's come to construction. It's made up of what? Let's come to the construction of the transformer, made up of what? So must, from the principle it's very clear, it must be made up of two coils. two coils must be there. But how those two coils will keep? How the setup, how will set those two coils? Now see, transformer, I am drawing the figure. From the figure we can go to the construction. I am now going to the figure, you see. So what is this one? Have you seen any previous lecture this type of figure? Have you seen this type of figure in any previous lecture? Yes, you have seen. Where? In minimization of eddy current. I have drawn one figure like this. What is this? These are the plates insulated from each other. So this is called lamination. Lamination is one method to reduce eddy current. Okay. So why I have done lamination? I will tell you. Just wait. And so this is the laminated core. And this core is made up of what? Wood. Not wood. Okay. It is made up of what? Copper. Not copper. Because copper is a diamagnetic substance. Okay. So all magnetic magnets have the allergy to copper. Okay. It's a diamagnetic substance. Always reduce everything. So what is this? Yeah. Favorites of the magnet, ferromagnetic substance, soft iron core. It's a soft iron core whose permeability, relative permeability is very, very high. Ferromagnetic substance. Retentivity less, coercivity less, soft iron, laminated core. So now you understood the construction. It's made up of soft iron, laminated core, and these are the two arms of the core. On those two arms, the coils will own just the coils. These are the coils. These are the coils will own here, and this is the input, AC input, and here another coil, you see, and will get you the output power. Maybe across any device, or I can connect one load resistance. Load resistance means is not any resistor. It's a device to which its output is fed. It's also output AC. I can write here output AC. This is output AC. This is input AC. These are the two coils. Coils are made up of what? Copper. It's a good conductor. Obviously, coils are made up of copper. So, the whole construction now you see. This much is the construction of transformer. So easy construction. Only take a soft iron laminated core on the two arms. The coils are owned on the two arms. This is called primary coil. This one is called primary coil. Primary coil. And this one is called secondary coil. This is called secondary coil. Primary coil and secondary coil. Coil. Which coils? Copper coils. Copper coils having many number of turns. Two copper coils are owned on the two arms of the soft iron core. This is only transformer. Very easy construction. Anybody can make it at home. You can make it at home. Just to bring the coils. Simple wires you can bring. Copper wire. And you take one soft iron core. If you cannot take any soft iron core, any metal type shape you can take. Any metal means ferromagnetic substance you have to take. Okay, iron you take and just you wound it. Then this is transformer. Very easy. But I have written here AC input. Why? Why not DC input? Because it's mutual induction. Mutual induction works, always works if AC connected. But if DC connected, only at the time of switch on and switch off. At the time of switch on and switch off. I have already told you many times this one. That mutual induction happens always if AC is connected, because AC always changes. So always EMF is induced here. So this transformer is purely one AC device. It is never connected in DC. If you connect in DC, it will not work. Just for a second, EMF will come to here at the time of just connection of a DC. Just for a second. And again, at the time of switch off also it shows action. Otherwise, it will not show the action if this is connected here. So it's a purely AC device. So now you got the idea about the construction of a transformer. Very easy construction it is. So I had made one transformer. Once you see, this is very simple construction. This is one coil, this is one coil. The coils are like this. One LED bulb is connected here. If I connect AC, if I connect AC in these two terminals, then this bulb will glow. Anybody can make it. But I have this is the arrangement of the coils. What I have done here, I have kept a little separation between them. This is one type of arrangement of coils. Or on the same core, just in the figure I show, you can own on the same core. You can do also this type of arrangement. You can do this type of arrangement. You can do this type of arrangement. But another, you will find in some books, another good figure, which is the actual proper arrangement on same arm. On the same arm, coils are owned on the same arms, one over the other. Here one coil, here one coil, this is one coil, and on the same arm another coil. On the same arm, you see. So they are connected like this. Here you can give input AC, here you get input AC, output AC, you can get on the same arm it is connected. I know already you have judged in which case the better performance will come. In which case? This case, or which one I have made in this case? Which case better performance will come? Obviously, the answer is coming to your mind. Yes, you are right, this case. Why? Because on the same arm both are owned. So mutual induction is maximum. Maximum. I have told you about coefficient of coupling. Coefficient of a coupling I have told. Okay. So the case maximum mutual induction will happen here. So this is the best case, best arrangement of the coils. Also I want to show you one transformer. You see, this type of transformer you might have seen. In market, these ready-made transformers are also available. So here you can give input. See, two terminals are there. And you will get the output here, you will get the output. But is the question coming to your mind? That two terminals will give input, two terminals will give output. We'll take output. But why three terminals are connected here? Because this is another type of a transformer. This is called a center tapped transformer. Center tapped transformer. Also about this, knowledge about this transformer is required in other chapters. The center tapped means three terminals will start from the secondary coil. One terminal will start from here. One terminal will start from here. This is also another terminal. So two terminals will start, but I am not going more about that. Okay, so you will understand this one in other chapter about center tapped transformer. This is called, if this terminal just I will hide, then nothing will happen. This now two terminals are there. This is just transformer. Which figure I have made? If this terminal is there, center tapped transformer. You can also keep it here. No problem. You can hide this terminal. So it's a transformer. Available in market, you will find from 220 volt input AC. It will give you, this transformer will give you 12 volt. Only 12 volt. 220 volt to 12 volt. You see. Also transformers are there in the market which provides 9 volt only. Only 9 volt. 220 volt to 9 volt. Then using that 9 volt you can do anything. You can recharge your mobile phone, but connecting in other devices. More things are there. Okay, directly you cannot give it to charge your mobile phone, this terminal. Many other devices are there. Okay, that which converts AC to DC. Rectifier is also connected in your mobile charger, inside your mobile charger. Also transformer is there inside your mobile charger. Because you connect the mobile charger to 220 volt, but your mobile charge at only 4.5 volt. Then you imagine that 220 volt, if it directly will feed to your mobile phone, then what will happen? So one transformer is there in your charger fast transformer is there. Transformer is a device which is connected in every circuit, everywhere. In your charger, fast transformer is there which decrease 220 volt to less value like 9 volt, 5 volt like this. Then that 5 volt AC converts to DC by the help of another device called a rectifier inside your mobile charger. Then that is fed to your mobile phone. So in your mobile charger, first device is transformer. The AC is connected to transformer. Okay, now you all got the idea about the transformer. This is the construction of the transformer. So this figure you can draw. Also this figure what I just erased, that figure also you can draw, no problem. Any one figure you can draw in the exam if the question comes, because this is a important derivation for exam. So next we will come to the theory of the transformer. So in theory, first we have to take what symbols we use here. NP. NP is the number of turns of primary coil, and NS. NS is the number of turns of secondary coil. Primary coil number of turns, secondary coil number of turns. Then now when input AC is given here, what is the EMF induced? EMF induced in primary, what is the EMF induced in secondary? What is the EMF induced in primary? That is EP. So minus NP d phi by dt. Have you remembered it? This formula, Faraday's law, minus NP d phi by dt. Then EMF induced in secondary, ES I am writing, minus NS, so d phi by dt. Equation number 2, d phi by dt. Already you know these formulas. Now divide equation 2 by equation 1. Equation 2 by equation 1. 2 by 1 you do. So what will get? ES by EP is equal to NS by NP is equal to K. K is a constant. K is a constant. K. This K is called transformer ratio or transformer constant. K. So NS by NP, ES by EP, this is the K. Depending on the K, transformers are classified into two types. So what are the two types transformers? Transformers are classified into two types depending on the K. So now let's come. What are the two types? First, type 1. Type 1 first. If K greater than 1, then what happens? K greater than 1. Then you see ES greater than EP, NS greater than NP. Means what to mark here? That means secondary voltage. This is the EMF induced in secondary coil. Secondary voltage is more than primary voltage. Secondary voltage is more than primary voltage. Means voltage increase or decrease. Primary input is given to primary. Thus the figure to remind you, just I am drawing a small figure here. This is the primary coil. This is the secondary coil. This is the secondary coil. Okay. So what happens to the primary coil? EP voltage, secondary coil, ES voltage. What happens here? When you ES greater than EP means secondary voltage increases. This is which transformer? Secondary voltage increases means voltage increases because output is always we will get from secondary. Which transformer this is called? Which increases voltage? Step-up transformer. Step-up transformer, and its construction is very easy. What easy? Secondary number of turns is more than primary number of turns. And how many times the number of turns will be more, that much times of voltage increase. You see, if this is 100, this is 200, this is 2. So if this is 2 volt, this will be 4 volt. Because ratio has to be 2. If this is 2 times, if secondary turns is 2 times of primary turns, secondary voltage will be 2 times of primary voltage. 2 times. If it will be 10 times, this will be 10 times. So just if you want to increase the voltage how many times, accordingly you fix the number of turns, because number of turns is in your hand. You will change only the number of turns. Is it right? So that means in step-up transformer, number of turns in the secondary coil will be more than the number of turns in the primary coil. So the symbol in exam, sometimes the question comes, draw the symbol of the secondary, draw the symbol of the step-up transformer. Step-up transformer symbol, primary number of turn, this is secondary number of turns, you see. Very clearly from the figure, it's very clearly we can observe that the secondary number of turns more. This is the symbol of the transformer. This much. Input is given here, output is taken from here, but this the symbol is this much. Input, output not required to show. Is the question coming to your mind? Sir, you show the two coils, it's right. But why two lines you have drawn between them? These two lines. Why you have drawn such two lines between them? Just I made those two lines. Let's make those two lines red color for good visibility. Now you see, these are the two lines. Why two lines you have drawn? Or you just draw it like this? What's the cause? No. Those two lines will never forget to draw, because in symbol, those two lines represent the core of the transformer. Those two lines represent the core of the transformer. So don't forget to draw those two lines. So this is the symbol of step-up transformer. Now we'll come to step type 2. Type 2 what happens? If k less than 1. K less than 1, ES less than EP. K less than 1, ES less than EP. And NS less than NP. So secondary voltage is less than primary voltage, means voltage decreases. Decreases. That is street side transformer, that road side transformer. So that is step, which transformer? Step down transformer. Step down transformer. And what is a symbol? Only just number of turns of secondary you make less than primary. This is primary number of turns and secondary number of turns you see, and two lines between them. This is the symbolic presentation of the step down transformer. This is the symbolic presentation of step up transformer. Symbol. But one question to you. Have you seen any transformer having value of k as 1? Value of k is 1. Sir, I have a transformer having the value k as 1. Do you have that? If anybody will tell, sir, I have a transformer having k value as 1, then all of you will tell that you are mad. Why the k value will be 1 in transformer? Because if k value will be 1, then ES is equal to EP. NS is equal to NP, means both side number of turns will be same. ES is equal to EP, means primary voltage will be equal to secondary voltage. Then why will you connect the transformer? If the input voltage what will give, that much voltage also will get. What is the use of the transformer? It is only used to change voltage, either to increase voltage or to decrease voltage by changing the number of turns of secondary coil with respect to primary coil. But if turns will be same, then voltages will be same, value of k will be 1, then there is no use of the transformer. Then you will think, why will you connect the transformer there, making k value 1? So no transformer you will find having k value 1. It must be greater than 1 for step up, must be less than 1 for step down. Okay, so this is the transformer ratio or different types of transformer. Now let's say one thing. So let's discuss how much power will give and how much power will get. Input power. Input power we are giving through primary EPIP, and output power you are getting through secondary, that is ESIS, EPIP and ESIS. But the transformer is called ideal transformer, where how much power will give, that much power will get. That's called ideal transformer. How much you give, that much you get. But you know, ideal things are just to discuss, just to tell, just to read in book, but not practically available in your day-to-day life. Not available in day-to-day life. How much power you will give here, that much power you may not get. Not may not, you will not at all get that much power. You'll never get that much power because the simple thing, due to different factors, energy losses in our day-to-day life. So let's see if how much power will give, that much power will not get. Then one word is there for quantitative discussion, for quantitative, to get a quantitative idea. What is that word? Efficiency. And what is always efficiency? What is always efficiency? Efficiency is the output power by input power. Output power divided by input power, that means ESIS divided by EPIP. Output power by input power. But I told you, for ideal transformer, what is the value of efficiency? That's 100% efficiency for ideal transformer where there is no loss, which is not practically possible. Just theoretically I am discussing. Okay, eta is equal to 1 means ESIS is equal to EPIP. Eta is 1, so ESIS is equal to EPIP. So that means ES by UC IP is equal to EP by IS. Right? So what you mark from this? What you mark here? What I have told you from the starting. So ESIS is equal to EPIP, means just both are inversely related, voltage and current. ES, or I can write it like this, ES by EP is equal to IS by is equal to ES by EP is equal to IP by IS. Both are inversely related. ES by EP is equal to IP by IS. Inversely related from the starting I told. It is a device which converts low voltage to high voltage. Then current becomes high to low. When voltage becomes low to high, current becomes high to low. When voltage increases, current decreases. When voltage decreases, current increases. So this is from this expression also, we now become very clear mathematically how when voltage increases, current decreases, and when voltage decreases, current increases, inversely related. But I told you there is no such transformer which is ideal, because nothing is ideal in your day-to-day life. Loss is there. Many losses are there. Due to what losses? No transformer is ideal. In practical case, what losses are there in the transformer? So now we come to the different losses of the transformer. What are the losses of a transformer? First let's come to copper loss. What is this loss? Copper loss. What copper is there? The coils are made up of copper. When current passes through the copper coil, copper may be a good conductor, but still some resistance is there. So due to that, heat generates. It is used, transformer is always used 24/7. So always heat is generated there. Some heat must generate. And our electric power supply, electric energy loss in the form of a heat. So that is copper loss. Copper loss means loss of electric energy in the form of heat energy in the wire or in the coil of the transformer. So to minimize that loss, we also will discuss how to minimize this loss. To minimize this loss, what we have done? We have taken copper wire. Then what else we can take? To minimize the loss, we have chosen such wire which has very, very less resistance. That is copper wire. So copper wire, but thick copper wire. If we take a thick copper wire, resistances will be little less. So to minimize this loss, you have to take thick copper wires. This is the method of minimization. Thick copper wires, it will take, more is the area of cross section, less is the resistance. Thick copper wires, this is the copper loss, how we can minimize. Let's come to iron loss. What is this iron loss? What iron is there inside the transformer? Soft iron core. But this iron loss is of two types again. One is eddy current loss. Eddy current loss. What is this eddy current loss? Eddy current also present here? Yes. Your soft iron core is a metal that is not connected anywhere, that is not connected to the power supply, that's remain insulated from the copper wires. Though no current is given to the soft iron core. But when you have owned the wires on the soft iron core, the current is changing in those wires. Means magnetic field also changing, so magnetic flux changes. So current constitute in that soft iron core. Though that is not connected to any power supply, but current constitute there due to change of a magnetic field, a magnetic flux. Which current? Eddy current. So electric energy loss in the form of eddy current. So that's called eddy current loss. But how will you minimize it? Lamination. That's why lamination is required. And in eddy current lecture, I had told you how by the help of lamination, eddy current can be minimized. So this can be minimized by lamination. We can minimize this. Next, come to next loss, iron loss. This is hysteresis loss. This is hysteresis loss, where you have listened this word hysteresis in magnetism and matter chapter. Hysteresis loss. You just remind that graph hysteresis loop. One graph was there like this. Hysteresis loss. The area enclosed by this loop, hysteresis loop, is called hysteresis loss. That's also energy loss. And where this comes? Due to repeated magnetization and demagnetization. Here the magnetization, demagnetization happens. Yes. Where? You have taken that copper coil, you are changing current. When you are changing current, magnetic field also changes. As alternating current changes, magnetic field also changes. So your soft iron becomes magnet, demagnet. Magnet, demagnet. That's soft iron core. So again another loss also happens in that core of the transformer. So that's why that's called iron loss. Another loss happens there. That's the hysteresis loss. Due to repeated magnetization and demagnetization of the core. How to minimize it? To minimize, how will minimize? If this loop will be very thin loop it will be, then minimization will be also less. And for which device this loop is very thin? That is soft iron. So that's why we are taking soft iron. Soft iron to minimize hysteresis loss. Laminated core to minimize eddy current loss. Thick copper wire to minimize copper loss. Then any other loss is there in the transformer? Another loss is there. That's called flux leakage. Flux leakage. What is this flux leakage? This happens due to improper alignment of the coils. I told you from the starting that this transformer, this man-made transformer, this one, okay. So this transformer, here the coils are separated more. The flux linked to these both coils will not be same, not at all. But when they wound on the same arm, then the flux linked may be same, but not at all. Flux linked with the two coils will not be same. But we have taken one assumption. Where we have taken that assumption? While writing the EP formula, you have taken minus NP d phi by dt. While writing ES formula, you have taken minus NS d phi by dt. What phi? What d phi? In both cases, d phi will be same? Not at all. But only you have assumed it, you have taken the assumption that in both coils flux change will be same. But both coils flux change will be never same. Because they are two different coils means flux change must be different. But to minimize that, at least we'll try to minimize the flux leakage. to make the flux change in both coils same? What we'll do? We'll try to own the two coils, primary and secondary, on the same arm. On the same arm, then the minimization will be less. So this is about flux leakage. This can be minimized by proper alignment of the coils. Then come to the another loss. Another loss is what? Magnetostriction. Magnetostriction. What is this loss? We have not listened any such word. Magnetostriction. Have you listened one sound while passing on the road just at the side of a transformer? Have you listened one humming sound? Like this? Have you listened this type of sound? Okay. This, if you have listened, then from where the sound come? From that transformer. Why? When the transformer become very old, due to vibration of the core, when it become very old, that the nut bolt those who are connected, that becomes little loose. So that core vibrates. When core vibrate, that humming sound come, and from that sound energy, from where it come? Our supplied electric energy converts to sound energy. So our electric energy lost there. So that transformer should be replaced. That transformer immediately should be replaced by the company, and one new transformer should be kept there. Humming sound, we can't minimize it, only we have to replace it, and we have to again modify that transformer. So the vibration of the core, the energy lost due to vibration of the core in the form of a humming sound, that is a magnetostriction. So these are the different losses of transformer. So this is all about transformer. Today we discuss what is this device, what is the construction, what is the principle, what is the theory, and what are the losses of transformer. So it's a very important 5 marks question, always comes in exam. And if a numericals will come, then you have to remember the formula, that what I told about